5 times. Thank you for your patience. I wrote it down wrong the first time. If you've just joined us, please flip to the very back of your packet. And then I'm going to start by doing this in groups of 2. Well, I know a negative times a negative is a positive. And as I just showed before I filmed this, if I take the square root of x times the square root of x, I simply get x. Why is that? Because x times x is x squared. The square root and the square cancel. I'm left with just x. That same concept. A negative times a negative is a positive. And I know the square root of 20 times the square root of 20 is simply 20. And if that's baffling to you, you could take 20 times 20 to get 400, and then the square root of 400 would be 20. So this group, multiplying these two, I get positive 20. That means multiplying these, I also get positive 20. 20 times 20 is 400, and a positive times a positive is a positive. And now I need to multiply that by negative square root of 20. Well, a positive times a negative is in fact a negative. And so I have negative 400, and I'm going to break 20 into the square root of 4 times the square root of 5. We know the square root of 4 is 2, so 2 times negative 400 is negative 800 square roots of 5. Look at another expression here. So I'm going to break this into groups of 2. You learned in this lesson that I squared is equivalent to negative 1. So I'm going to go ahead and break this into I squared, and I. So there's a total of 5 i's, 1, 2, 3, 4, and 5. And the same thing, I squared and I squared. Now each one of these I squared is equivalent to negative 1. So I have negative 1 times negative 1 times 5 with an I in back. Negative times a negative is a positive, so this is positive 1 times 5. I have 5i on the left, and on the right-hand side, to the right of the negative sign, a negative 1 times a negative 1 is a positive 1. Now when we write this down, this complex number, we want to put it with the real number first and the imaginary number second. And it's going to be separated by a plus or minus, whatever it is. So this is negative 1, and now the 5 is positive, plus 5i. Let's go on to our last one. So for this one, let's write down 3i over 4 plus I, subtract 2 over 4 minus I. Okay, so the first thing we do is we need to be able to combine these, and we do not have a common denominator. So I'm going to do what's called the butterfly method. If you look it up, Mr. McFarland calls it the McFarland method. So we're going to multiply 3i times this quantity, so 3i times 4 subtract I. I'm going to drop down the subtraction sign. And then I'm going to take 2 times the quantity, 4 plus I. And this is all going to be divided by pushing these two groups together, 4 plus I and 4 minus I. So my first step is I'm going to try to simplify what is in the top, or the numerator. I'm going to take 3i times the 2 quantities inside the parentheses and then negative 2 times 2 quantities behind it. So I'm going to do that off to the side here. So 3i times 4 is 12i, and 3i times negative I would be a negative 3i squared. Then I'm going to take negative 2 times 4, which is negative 8, and negative 2 times positive 1i is a negative 2i. Before I even look at the denominator, let's see what I can do here. Well, I know that I squared is negative 1, so negative 3 times a negative 1 is a positive 3. And now I'm just going to combine like terms as if we were doing this. If I said to you 12x plus 3 minus 8 minus 2x, you'd know exactly how to combine like terms, right? Your 12x, your negative 2x would go together, your 3 and negative 8 would go together. Same concept over here. I'm going to start with the reals. Positive 3 and negative 8 is a negative 5. 12 and negative 2 is a positive 10i. So I've combined in the numerators, and now I'm going to look in the denominator. Remember this, we can save ourselves time. When we have the exact same thing, the only difference is what's inside what's only difference is what's between the two terms on the left and right. We get to cancel out doing the O and the I because they would just simply be opposites of each other, additive inverses of one another. So when they're exactly the same except for the sign in between, I only have to do the fronts and the last. Multiplying the fronts, I end up with 16. Multiplying the last, well, positive I and negative I gives us a negative, a positive times a negative. And I times I is I squared. Now, really, what is I squared? I squared is equivalent to -1. So this becomes 16 plus 1, which is 17. And you may see some stuff like this on the test. Mr. McFarland does want us to separate this if we look at the answer key. So the real portion is -5 over 17, and the imaginary portion is 10 over 17i. I'd like to do one more that's a little bit even easier than that. So let me flip this around so we do have space. I don't have to waste any paper. And let's start by writing down the following. Let's do 7 over 3 minus 4i. When we go ahead and simplify this, we can't have any i's on the bottom. So how do we do that? We need to multiply by the conjugate of the denominator. The conjugate of the denominator says we write the first and the last term, and whenever you multiply it times the bottom, the denominator, you must also multiply times the numerator. The exact same thing, so we don't change the value of this original fraction. So it was subtraction in between, now it's going to be addition. Okay, so I'm going to start by just distributing the 7 to get 21 plus 28i. Now they're exactly the same. The only difference is going to be the signs on in between the two terms. So again, we only have to do the front and the last. The front, 3 times 3 is 9, and the back, positive 4 times negative 4 is negative 16, but then we have I times I, which is I squared. Now, I'm going to be lazy, and I'm fine with you being lazy. After we're doing this, I'm okay with you then just kind of crossing this out and writing down a -1. 9 subtract 16 times -1. So I'm taking -16 times -1. Well, that's a positive 16 because a negative times negative is a positive, and 9 plus 16 is, in fact, 25. So we're going to break this apart now. I have 21 over 25, that's the real portion, it contains no I, and 28 over 25 would be the imaginary portion of a complex number. I did see a mistake, one of you brought it up to me. If you could flip to the side, I will find the mistake here. It was one of them on this side. Which one is it? 17, I believe this is supposed to be positive right here, correct? So 17 should have been positive 2 square roots of 3.